Okay. Thank you so much, everyone. Thank you for joining again today. This is our day 17 of the Unlocking Your Code Superpowers, day 17 of the Code Hero journey. Thank you for joining again. If you have been here for day one, type 100%. 100% if you have been with us from day one. If you are not, just type 50%. We understand. So if you have joined us from the beginning, type 100%. Let's know those who are with us. All right. So today we'll be going into back to the back end, and to do that, we'll be considering creating what we call persistence, and then CRUDE operations, CRUDE, and then we'll look into database SQL. So we'll take a look at this. We'll take a look at persistence, we look at CRUDE operation, we look at database, we look at SQL, and then we go into what we call JDBC, which means Java database connectivity. So we will look at SQL, structured query language. We'll look at persistence. So without wasting time, let's go back to our earlier project in the database. So in the database, we have an address which contains, I explain what package means. Package means a way of structuring, projects. Package is a way of structuring projects or codes, organizing codes to keep related objects to related objects. So we are going to start making use of package very well. So we will see how we can organize our code very well. Now here currently we have everything in the edu. We have everything in edu, but we want to do something more interesting. Instead of the edu, we will have inside edu, let's create what we call sub packages, that is subfolders, to clearly organize our code. First, I'm going to create one that I will call DAO, which means data access object. I'm also going to create another folder. I will call it service, which will host our service classes. I will have another one, maybe control. I will call it controllers. Controllers. Controller should be in edu. So I move it to edu. So we have edu, we have controllers, we have DAO, and we have service. And then the root of our package, the root of our package is in the edu. So I'm going to move the app to the edu folder. The app to the edu. Okay, it's already in the edu. However, the students and address, they are objects. Students and address are objects. So I'm going to move the object to the data access object. You understand? Okay, or do it like this. Let's create another one. Let's call it since they are just data. Oftentimes DAO is used for connection. I will also have something I will call a repository. Repository, like a way repository. So we have repository, we have controller, we have DAO, we have a service, and for the objects, let me call them VAO. I'll call them VAO. VAO means value access object. So let's have this. So, and then I will move the address and student. Address and student. I'll move them to the VAO package. Address and student will go into the VAO package because they are our value access. When we say value access, it means that they are objects that just hold values. They don't do any other thing. They just hold value. That's why we call it value access object. Then we also have data access object, which is the same thing as the repository anyway. So we can delete either of the two. So of course we can have getter and setter for our, so the package will now be for the object will now be bootcamp.edu.vao, bootcamp.edu.vao, bootcamp.edu.vao. Okay, I'm trying to slow down now. bootcamp.edu.vao. Now, I was explaining packaging as what? As organization of related codes that are related. We put them in the same folder. We organize them in the same folder so that our folders can look clean. That is essence of packaging. And what is the folder is not readily accessible to the other folder except you import those classes. Classes. So here, what do we have? So we have address. We have address. We have address, street, city, state. We have get city. We can have a get street. Public string get street. Don't forget, this is just a getter and setter that we have. So return this dot street. So we have the address now in the VAO folder. The student will also be in VAO folder. So the package name should be what? Will also be bootstrap.edu.vao. bootcamp.edu.vao. Now, so that is data access. Now, let's say we want to create students. We want to maintain student collections and things like that. So I will create. I'll probably create a repository for students. That is how to access the student object and things like that. So let's have a repository here, and in this repository, let's create something called students or student repository. I like to always use plural. So if you look at it in our repository, we will have students. We have bootstrap.edu.repository.students. And this student, what do we want to do? We want to create a verb of CRUDE. CRUDE. What is CRUDE? CRUDE in this context means create, read, then delete, and then E is actually for updating. We have C for create, R for read, and then U for update, D for delete. Okay, so these are the verb for when you have objects. So we are going to create an internal collections. That's what we started with initially. So let's have a list list of students, list of students, list of students, list of students, and call it students. Right, so we have list of students, call it students, and then this class public, let's have a constructor called students. Right, so we have a constructor for students, and then in this constructor we want to initialize students. So students, so we are saying that this dot students equals to new array list, right? So we have instantiate our students here, right? So student, list of students, and then we have this dot students, list students of student. We initialize this, and then we can read here, since this list is representing just like our database record scientist, like that. Currently we have list. Let's import list. So import java.util.list. Now we also, this class is repository class. So if you try to compile this class now, it will throw you error. It will throw an error. Let's try it. Clear, and say Gradle. I want to Gradle build. So if we do that, you will realize that there is an error. And let's look at what the error is. Okay, I'm in the Bootcamp. Okay, let's say database, right? So Gradle clean build. Now, so if we look at this, you will see that it says that, okay, cannot resolve dependency of repository. Okay, I'm coming back to that. So let's for now I'll comment that out in the build file. Let's comment that out. I'm coming back to that since we don't need that dependency. So our build now, so if we check, you will see that there are errors here. There are errors in my apps, but basically in the student, you will see that in the student, it's saying that cannot find symbol students in class students. Why? The reason being that we have not imported students. We have not imported students. So let's handle that. So in this student class, we need to import students because they are not in the same package, unlike before. So we now say Bootcamp. We import bootcamp.edu.vao. That's where the student is. Then the students. Now in student class, we will not need to do that. For student class has a dependency called address. However, address and student are in the same class. They are in the same class. So with that, we will not need to import. So let's say, because we have not gotten here, I will comment some things out. Okay, so let's build again. Let's see. Okay, this is still not part of our what we are doing. So I'm going to probably comment all this out. I'm probably going to comment all this out. Let's see. Also, there SQL exception not thrown. Okay, say try, and then where is the SQL exception? So this exception was not thrown, so let's keep this. Let's keep this. So we'll probably leave this. Let me see. Try catch exception. Class not found was also not thrown. So if it's not thrown, we can comment also this out. Let's see. Okay, we have build successful. So we have build successful. We've been able to compile the code now. We've been able to compile the code. So for the students. Now let's go back to what we want to do originally. So if we go back, so we have the class students and we just initialize students. So for every create here, I will turn into a verb called add to my collection. So I'll just say public void add, and then I will say student, right? I'm adding a student, so I'll just simply say this dot student, which is the records, dot add student, right? Say final student. So let's just have this. That's for add, and then we have a create, which is now our add. So let's just add comments to it. Just put Java document comment. So here we are saying that this creates new student, right? Okay, so we have a student. Now, what else? Let's go to read. To read means that to fetch. And there are two types of fetch now. You can fetch a single item or a single record, and then you can fetch multiple records. So for the first one, single student, so public string, so public, we are returning a student. So if a student is found, let's say we return the student. If the student is not found, we return null. So let's just say find by what should we give? Should we find by number or by ID? Let's say find student by ID, which means that every time a student is created, we add a student ID to it, right? So how do we add student ID? Let's use a simple method of generating ID. And the simple method of generating ID, thank you for joining, Catherine. Simple method of joining of creating an ID is let's just find the length. What's the length? And incrementing the length. So currently our students is a list, so which means we can get the total number, isn't it? And the total number in a list is called, it can be gotten by using dot size. So we can say integer ID equals to students dot size plus 1 plus 1. So because if there is nothing in the list, the size will be 0. If there is nothing in the list, the size will be 0. So that is why we are incrementing it by 1. So if you add another student, if the size was already 1, then the size increases to 2. Then which means this student, we need to also update it. We can now say student dot set ID, this ID that we have just generated, before adding it to the collection. Now, but we don't have ID in students. So let's go back to students and add ID to it. Let's go back to students class. Here we have say private integer ID. I'm using integer object, which means that when the ID is not given, the ID should be null. And then so let's have a getter and setter for the ID. So public integer get ID, and then we'll say return this dot ID, right? Then we can have a set ID, public void set ID, integer ID, and then we can say this dot ID equals to ID. So we have ID set now. We have ID set. We have ID set, and so if we go back to student, here, we will see that we already have set ID for students. And then we add the student to collection. Now we can say find by ID, final integer int ID. Let's say this. We have find by ID. So here, what do we do? How do we find by ID? Is that we can take a look at the collection and iterate through it. We iterate through the collection. We iterate through the collection, and then put the if the ID equals to the ID that we are looking for, then we return the object. So for students I think I told us about object for loop, where you, instead of using for integer x equals to 0, x less than or equals to the length of the records, s plus plus, you can also replace it with this, where you have for the object type and the variable for the object looping through the collections. So for students, we can say if students dot get ID equals to ID, then we can say return students. Otherwise, if we look through everything, then we have not found the student, so we can return null. This is more performant when you are writing doing algorithm test, because if you don't return in the middle of this, you might end up looping through. Even if there are 1 million records and the student record is at the first item, you might still end up looping through the whole before you return the actual student that is found. So we return the student that's found by ID. Now another one is that we can return all the students. We can return all students. So we can say, okay, public or public list students, public students, and then we can say find all students, find all. So if you do find all, and then we have this, then we can say return this dot students. So that is returning multiple. Imagine we want to find all the students within say a department, or all students that belong to a particular address. As long as we are expecting something that is more than one record, our return type should be a list. Our return type should be what? A list. So having done that we have dealt with the create, we have tried with read. What about update? Let's say we want to update the address of a student. Let's say we want to update the address of a student. Then so we can have, say, public void update. Let's have update, and then we have a student. You understand? Or let's say yeah, so let's say string student integer ID, and then say string address, or street. Let's just say street is the street that we want to update. So what do we do? In this context? How do we update the student information? First, we need to ascertain that the student exists in our record. So let's put a comment here. Let's put a comment here and say one, find the student that it exists. Find the student with given ID. If not exist, return. Otherwise, what should we do? Otherwise, update the address and put back into the collection. Now here, so we'll first find the student whose ID. Yeah, you see the same for loop, but one, it is cleaner. It will reduce your for loop line by one. That's what we call a code optimization. So this will reduce your for loop code by at least one line. That is one. Two, it also shows that instead of casting to a particular data type, you already know the expected data type of the object you are looking for. The traditional for loop can still be used when you need to make use of the index or position of that item within the collection. Please like the video as you are on. Like the video, make your comments. Like the video, make your comments. Like the video, make your comments. Okay, so we'll go on. So let's look at it. This is step 1, find it. Step 2, if not exist, return. Step 3, do what? Update the address. So let's start with step 1, find. We already have a method called find find by ID. So we don't need to write that code again. That is one of the concepts of OOP, concepts of solid. I talk about dry. Don't repeat yourself. Don't repeat yourself. Dry, D-R-Y. In case you are asked in an interview, means that don't write duplicated code. Avoid duplicated code. So how do we avoid duplicated code? Write a code, a method that has a single responsibility. And so the code should also be what? Reusable code. So we are teaching ourselves about reusable code. So we have a student equals to find by ID, and then we'll pass the ID. So that's the step 1 in our comment. Step 2 is that if it does not exist, return. Don't do anything if you can't find the ID. Later on, we are going to modify this class to probably throw an error, with a message like student does not exist and things like that. All right, so let's do it that way. And what else is that we now have student if student equals to null, that means doesn't exist, then return. Don't do anything. Now if it exists, so there is no need to say else. If it exists, we can now say we first get the address. We'll say address equals to student dot get address. Student dot get address. So now that we have the address, we want to update the streets. Then we can now say address dot set street, our incoming street. After we have done that, we will now set the address back. We will now say student dot set address, this address. So student dot set address, I think double D, right? Double D, yeah. So we set the address. Now let's see whether we have a set street in student, in address itself. So in address we have street, city, state. We have get street, we have get city. So let's say set street. Let's add set street, public void set street, final string street. And here we are saying that this dot street equals to street. This dot street equals to street. So we set the street. Don't forget, on your own, implement every other getter and setter. On your own, implement every getter and setter. On your own, you can implement every getter and setter. Now that we have that, what else? So we go back to our students repository. So we have find by ID, then we have this, we have set address. That completes our updates. Now, so the next one is if we go back to it, we have create, we have read, we have update, and then we have delete. Okay, for this one, even though we have set the student, we need to put it back to the collection. So what do we do? What do we do is that we can say students, which is this dot insert. I think there is an insert method at a particular index. Array is zero index base. So, and don't forget, when we are creating the ID is actually the size plus 1. So let's take minus 1, and then we'll put student. That put this student back to the position it is. Otherwise, we will lose that position. We will lose that position. We will lose that position. You know, we will lose that position. So we have this. Finally for this, let's have the delete. How do we delete? The same way, we look for the object. If we find the object, we do what? We remove it from the collection. And if it is already deleted, so we can do it this way. Now, if we delete an item, from this list, the size will be shortened, and that will affect our ID, which means that we can have a collision of ID. So we'll simply set it to null. Do you understand? So let's say we have a public void delete, and then say we have a integer ID, so we'll say student ID, student equals to find by ID, right? So after that, then if he doesn't exist, we return if student equals to null, then we'll say return. After that, then if it doesn't, we can now say student dot set, insert ID minus 1, that's the position, and then we are putting null there. Which means that that object does not exist again. It has been removed. So that completes our CRUDE operation. CRUDE means create, read, update, delete. Create, read, update, delete. So we have a repository to handle this. Let's go ahead and compile our class. So we can have we can have a Gradle clean build again. Let's see. Okay, I think there is a compilation error. It says what? It says address, symbol address not found. Let's look at address. What do we have in the package? Address should be in Bootcamp, right? Bootcamp, we have bootcamp.edu.vao, that's address. Student bootcamp.edu.vao, and then in this students class we should have bootcamp.edu.vao.students. So we'll try and fix this. Address addr, what is this? It's called address in student, right? Student as address, right? Okay, so, and they belong to bootcamp.edu.vao, address bootcamp.edu.vao, and in student we are going to import bootcamp.edu.vao, rather students. I think this is correct. Then say method insert. Method insert. I think insert has to, maybe we change that one to add. Add from a particular. Add to a particular endpoint. How to at an index. So let's put it at an index at interface. So so I'll probably use add instead of this. Let's change it to add to insert at a particular point. Add okay, so I fixed that. Students, and then students dot add. Student dot add. We have one more error, and the error is cannot find symbol. Student dot get address. Line 44. Let's look at students. Line 44. Here we have address. Okay, we'll probably need to import address too. Let's import address. Address is not imported. So import bootcamp.edu.vao.address. Yeah, because it's not in this package, so we have to import it. So that said, so we can go back to recompile and say Gradle clean build. What else? Set address in student. Set address in student. Let's look at students. So we have address. Student has get address, but we don't have setter for the address. So let's add the setter and call it public void set address, and that will take a final address. So then we have this dot address equals to address. All right, so let's clean up and build again. Now it is successful. So they're successful. So we have student, we have address, and things like that. Let's just say we want to print this student. When we have a student information, let's override. We can override at override public string to string. Now every object has the toString method, because an object is an interface. An object is an interface that when you that has a method called toString. This method can be overridden. Overriding a method means that you update whatever thing that the method is doing. You can change the content of what the method or the logical content in the code block. For example, if we have printed student, you probably see like a jargon like that. Okay, before we do that, I will just let's do like this. I will just take this away and let us print student as it is. So let's go back to our app. In this app, what we want to do is that we want to create students. We want to create students. So let's say in this app, this is our app. Let's have a method here. Say public void create student, and then we have string name, string street, string city, string what do we have? Street in the address. Let's see what we have in the address. We have street, city, and state. So let's put state. Let's put state. Let's put state. So now that we have done that, now in our app we have create student, and this is it. So what do we do with create student? We need to have a name, street, because a student has a name. What else does the student have? Let's look at it. The student has name. Okay, name and just an address. Okay, so if we go back to this, then we already have in this place we have a student, so we can create a dependency for this class and we can have students. Say private final students, call it students, and then we can initialize our students here and say we can say so students equals to new students. All right, so we have student, but we need to import the student, and the student is in a repository class. So we already have this. We have student in repository class. So now we have that, and then we have a method called this. This is our app, so we add the main method. Say public static void main string array, right? String array args. So we have this for students. And then, so because this is our entry class, this is our app, we can say app equals to new app, and then we call the method of the app. What do we want to do? We want to create student, so we can say app.create student, and for the student we have name, so let's give it a name, Donald Bello. Street, let's give it a street name, Testosterone 1. That's the name of the street. What else? The city, let's say, what's the name of the city? The name of the city is Ontario. And then after the Ontario city, we have states. I'll just put CA, anything just to so that creates a student. But let's have multiple students. we can say GA, and we can say Johnson's. We can say Testone 2, 2, 3, and then we have a Kike, Jake Clark, and say Tokpe Samson. So and then say London Avenue. Let's put it that way. So we have like 3 students. So where I'm going to is this. So let's say we want to print everything now in student. So let's say public void print all. Let's say print all. Or just print without all self. Let's say print. What do we want to do? We just want to print everything in the collection. So we can say for the student is one that is adding student intent, so that we can just say, okay, in that case, let's just have list of students, and call it students equals to students dot get all. No, is it get all or find all? I think we have find all. And then because we already have students here, so I'll call it records. So since student records equals to these dot students dot find all, right? So dot find all. Then let's print. We'll now say for student in students system dot out dot print line students. So let's have this. So we have a method called print, and what the method print is doing is to print all. Is to print all the students that have been created. Print all the students that have been created. So how do we handle this? So first, we fetch all the records. Let's see whether we have find all in our student repository. Let's say if we have find all. So we have find all. Now if you go back to the app, we have not actually implemented create student. In the create student, what do? We call this dot students dot add student, but we now need to create the student object. How do we create the student object? First, we create the address object. So we say address equals to new address. Address equals to new address. And that if we go to the address, what is the constructor? Address as street, city, and state. Address as street, city, and state. So we have street, we have city, we have state. So we have created an address object. Now the student itself. So we have student equals to new student. And the student has a name and address. student has name and address, then we ask student. So that is creating a student. So we are just looking at how to create students. How to create a student. I need us to be able to follow it all through. So we have created a student and added the student to the backend record by calling the student repository, the add method on that student. Next, we are doing a print, which is where I'm actually taking us to student. So if we come to the main method and we say app.print, app.print should print all the students, information. So we'll probably go back now. Let's recompile. Let's build the Gradle build. We have an error, so we probably need to import our students. We need to import students, right? So and this has to be records. Let's see whether, so we have students. We also need the address. So import bootcamp.edu.vao.address. Import bootcamp edu.vao.student. You see the difference? There is one that is students and the other is student. The students is in the repository package. The VAO is the data access object, value access object to hold just the values. Then we can try and compile or build the project again. Let's try and build again. Here we have students. Okay, it was not saved. It wasn't saved. Now you make an update, then you save the changes. So we have one error. List. We need to also import list. So import java.util.list. Import java.util.list. Import java.util.list, and we'll compile. What do we have? It says compile successfully. So if it's successful, then let's try and run it. Probably say jar, because this will have produced a jar file, and then so java jar. In our build folder, I told you in day 16 you will have the binary file, so which means your project name. So build, if you're on Windows you use \. For Mac you use /. The jar file is in the build folder and in libs, then in database.jar, then we run it. Good. So we can see welcome to address admission unit, then database connection. Okay, we are not on all that. I'll probably do this. This one to have a clean code, so we don't miss a lot of stuff. I'm going to take this away. Okay, so let's take that away, and then I'll probably create a new file and put that there. So here, so you can see we have in the app, we instantiate the class, and then at the point of printing, we print all the student record, all the students record. So let me just put this one, system dot out dot println. Let me use student records. Let's put it that way. Let's call it student records. So if you build again and you run the code, you have this. So you have welcome to admission unit, and then student record. We'll print student record. Let me just put some decoration around it. So here I just want a ruler under it. Let's have a ruler under it. We'll put a ruler also here. Let's put a ruler here. Maybe on top too. Okay. If that is case, and we have this. Welcome to admission unit. All right, this is just a aesthesis. So we have this. Welcome to student record. My second pipe is outside. All right, so we are printing the student record, but what I actually want to point us to is that you will see that, look at how the student object were printed. That is for the object, that's the default way of printing. We just put the package name and the class name with a kind of class signature. That's how it's printed. Now we want to override it. We want the student to be printed out meaningfully. We want the student to be printed out meaningfully. So we can go ahead and change the way print is being done. So let's go to the way print is being done. Let's go to student object. In the student object, we will override, that is, we will modify the toString method. That's actually the method that prints out any object. So you can add it to your class to print the object as a human readable string, string. So we probably we will split our session today. We will stop this in another 17 minutes. Take an hour break, and then resume the second session where we'll be dealing with the database and SQL. I think we can do that. So here in the toString method, let's modify it. I want you to write the student's name and the address. The student name and the address. So what are we going to do for the student? So we just say, let's say string description equals to this dot name for the student plus you can just do string concatenation, space address plus this dot address dot address dot get street plus let's just put space in between and say plus this dot address, right, dot get city. Then let's add another space in between, so plus this dot address dot get state, this address, this dot address dot get state. Let's be sure that get state is in the address. Let's check get state. Yeah, so let's look at get state in address. Yeah, in the app you can call student.getName plus student.getAddress, but there's a better way to do that, which is just override the address, or the student to string method. And so with that, you will not need to modify anything anywhere. So that's why we are doing this. Let's check the students. Let's check the address. Does the address has get state? There is get street, but there is no get state. So we will add the public string get state, and then with this we return this dot state. So we have address, we have get state, we have address, and then we have get state. So if you go to the student object, everything should be fine here. Now after this, what's the next thing? The next thing will now be to recompile again. Let's recompile again without doing anything. Let me fix here. Student line 39. Okay, sorry. So here, this is the description, right? So we just return this. Return, because we need to return the string, the generated string. Okay, of course you can take this one to the new line. You can take it to the new line if you like. You can have something like this to be on the new line, as long as you have the plus. So we have the address, get state, and things like that. So if you go back and build the project, it's built successfully now. It's built successfully, and then you can run it. When you run, you will see that the student data is now printed correctly. The student data is now printed correctly. Because of what? Because we have modified the toString method. We have modified the toString method. If you want to do it better, don't forget that this dot get straight, you understand, this dot get straight, this is a way, this is one way. Another way is that this dot get address, dot get straight, and things like that. We can take it because they are address information. We can actually take this out from address and say, we can just say this dot address dot to string. We can also do it that way. You will see that the code is shorter and cleaner and clearer this time around. So we have this to string, which means we will implement to string for address. We will implement to string for the address. So let's go to the address. Let's go to the address. If we get to the address, we can now override the to string method here. Override, and then say public string to string. So how you want the address to be formatted, you now put it. So here I'll just say return. So instead of get street now, I don't really need to call get street. I'll just say this dot street. Then this one, this will now be this dot city, and then this will be this dot state. So here we have also made the cleaner, like in the student object, we took the name, we added address to it, dot to string, and here also in the address itself we implemented a to string, and we say in the to string the address should come out like this. We can even say that, okay, the address should come out like this. Let's say, let me put an arrow before the 8 and say that like this is our address will come out. So say plus a street, right? After the street we have comma, we have the city, and then we have the state. Maybe city then comma state. We can also do like this. We have just formatted the string. So if we rebuild the project and run again, we will have this. You can see that this is also clearer. It's more readable than what we have initially. You can refresh your screen if you have not caught up with where I am. You know, you can just refresh if your video rendering is slow. Just refresh and you see where we are. So we have 8 minutes to go for this session. We have looked at package design. We are looking at how to put related code into related stuff. But don't forget, in good application design, I mentioned some stuff. I mentioned some concept of OOP that we need to follow. And in that OOP, I talk about solid. I talk about dry, right? So, and in solid, we are saying that we should have what? Single responsibility. Single responsibility. It should be open. It should be open for extension, but closed. Open for extension, but close to modification. It should not be modifiable. You understand? It should not be modifiable. And then you can add the dependency, or reduce dependency injection. Like if you look at the address class, we have the address class, we have student class. Student address is a dependency because a student needs an address in his dependency. So instead of writing a class that has both the student and the address detail, by our design, by solid design, you should separate them. to different concern. Then dry means what? Don't repeat yourself. Don't repeat yourself. That is, avoid code duplication, and then make code reusable. Make code reusable. Make code reusable. In OOP, we have discussed encapsulation. So here we have hidden like address data and provided a getter and setter for it. And then we have talked about, we have not done interface, so we'll talk about that. Interface allow you to maintain a contra, so that you can hide the implementation, enable you to hide implementation. So we also have data as abstraction, where you can abstract the details. If you have a class, that contains data, and you have another class that contains almost the same thing that the first data contain or the first class contain, what you do is that you extend that class so that you can keep the data from the parent class. Having said that, if we use that and go back to our class, this is the entry class. The entry class should remain an entry class. You should not do any other thing other than being an entry class to trigger every other thing that needs to happen in the class. So in this context, this class is creating student, is doing printing. It is very wrong by design. So that is why we are going to create another class that is responsible for what we call factory. They call it factory design in some place. The factory design is for you to create, or creational classes that create other classes and things like that. So we move this action to another class called service. So we have a package called service here. There is nothing there. So let's call it student service. Let's create a class called student service. Student service.java. Student service. And in the student service, we want to create students, we want to update students. The service class most times is one that collects the parameters. The service class collect the parameters. So here our package will be edu.service to represent the service package. Okay, so having said that, we can now say that in this service should be the one to maintain connection to the back end, connection to the repository class. If that is the case, we will move everything that we have here. We will move everything about students here. We will move it to our service class. We will move it to our service class. So here, student service, and then we'll have a constructor. So public student service. This student service will now handle the students. So this students equals to new students, which is our repository, and the student is in the repository class. The student is in the repository class. So this students equals to new students. What else? We will take of course all these objects here, we'll move them away. Okay, let's move this away and bring them to our service class. Let's move them to our service class. Now that we have that, next is that we have create student, we have print students. Let's take this one out and then bring them to the student class. Student service class. Student service class. So student service class. Okay, so in the student service class, we have address, we have student, we have the repository. We've instantiated the repository, and then we handle this, we handle the add, and that's it. So we have created a student service. So what are we going to do? We are going to create student service here. So we are going to create student service. So in this app now, we can now say student service. We will now have what we call the dependency injection. Let's say student service, student service. Right. So if we instantiate student service here, we can now say this the student service student service equals to new student service. Right. This service equals to new student service. Let's round it up. Now that we have student service, we need to import this student service. Say import Bootcamp. It's a bootcamp.edu.student service. So, and here we can now say app. So since that we have a student service now, let's say we have a list of students here. We'll now say let's say public void create student, that is create multiple students. So we can now move this guy. We can move this guy out, and we move this guy out, and then this dot student service will replace this dot app dot create student, and then print. So here, after instantiating the app, we'll just do app.create students. So our code is neater now, is cleaner. We have removed all jargons from here. We have removed all jargons. From here. So we have a student bootcamp.edu, which is our base class, and then we import a student service as a dependency. We instantiate the student service, and then we call we have a method to create multiple students and print them in the student service. And in our main method, we can just call app.create students. So we can just compile this, build our project again. I'll say it's successful, and then we run. You see that we see have it. No issues. Student record created, but our app is more readable, maintainable. You know where to go to modify. If it is just student you want to modify, you go and modify the students. So you go and modify the student. We go to modify the student. We go to modify the student. Okay, I think we can continue. I thought my meeting is now, but I think we have 1 hour, 1 hour more. We have 1 hour or 2 hour more self. That's a good one. That's a good one. I think you can roll. If you support us to take a break, say break. If you want us to move on, put ride. If you want us to move on, write ride. If you want us to take a break now for another session, write break in the comment section. Let's do that now. Let's do that now. If you want us to continue, write ride. If you want us to take a break, write break. So let's take a vote fast. Let's take a vote fast. That's not an option. That vote is not counted. That vote is not a void. It's either right or break. So one ride, one break, one which is not an answer. We can break for 30 minutes. We can break for 30 minutes if you will want that. So we have 6 people watching, and then I have a vote from 3 people, but only 2 valid votes. Only 2 valid votes. Only 2 valid votes. So we have 4 votes. We have 4 votes. 2 in favor, 1 not in favor. Okay, 2-2. 2-2. We are waiting for the rest too. All right. Without much ado, we will break now. We'll break now and resume in another 30 minutes, where we'll be facing school. So thank you. We